I just thought I'd go through this paper from 2015, November. It's the non-calculator paper, and we're going to do questions 1 to 18, which will take about an hour. And the remaining 4 questions I'll do on another video. Right. This chap wants to go on holiday, and he's going to get a loan to do it, £720. And he's got to pay it back with 15% interest, and he's going to do this over 12 equal monthly instalments. Now the question is, how much will he pay back each month? Now I like to do it like this. Let's have a look. We're going to, so that's the total amount. Let's work out the interest first. The interest is going to be times 15%. My percentage is out of 100. And the other thing is, we've then got to divide that by 12. Now if we know our tables, we can see that 12 divides into 72. So that will go in 6 times. And also this 0 will cancel with this 0. And now we've got 6 times 15, and then it's divided by 10. Or you can do it this way round. 15 divided by 10 is 1.5. So the interest is going to be 1.5 times 6. Well, half of 6 is 3, so 1.5 times is 9. That's our interest each month. Now the other thing is, the amount we've got to pay, we have to pay back the loan as well, which as we saw was 720. We've already done this bit. 720 divided by 12 is 60. So we're paying back that much of the loan each month, this much of the interest. So adding those together, and we're £69. Okay, that's the first one done. So we've got question 2 now. Use the fact that 5.4 times 36 equals 194.4. And we're going to use it to find the value of 5.4 times 3.6. Well, the only difference between 3.6 and 36 is a multiplier of 10. So because that reduces, that's 1/10 of that, this is going to reduce by 10. So we can say that one will just equal 19.44. Put it over here. And this one here is, that's 54 is 10 times bigger than that. 360 is 10 times bigger than that. So it's 10 times, which is 100 times bigger. So that one is going to be 1944, and we've got to put a 0 on, and that's the answer to that one. Now the other thing to bear in mind is it's total for questions 2 is 2 marks. So we've got 1 mark for this answer, 1 mark for this answer. There's not really any room to have to show any working as such. Question 3. Here are the first 4 terms of an arithmetic sequence: 11, 17, 23 and 29. Find in terms of n an expression for the nth term of this arithmetic sequence. So usual thing, we find the difference between them. The difference between them is plus, how many there? 6. Is it the same here? Yes, plus 6. So it's a straightforward, as they say, arithmetic sequence. We know it's adding 6 each time, so we know it's going to be 6n is one part of it. And the other thing is, this is what I like to do, is take 6 off this first value. So go minus 6 off of 11, and we're going to get back to 5. That would be the zero term, if you like. And so we're going to add on that 5. Find in terms of n an expression for the nth term of this arithmetic sequence. It's an expression, so we don't need an equal sign. Let's just check it. If we put the first value in here, that's the first value, second value, third value, and fourth. We'll just put the first one in. 6 times 1, 6, add 5 is 11. We'll try this one. 2 times 6 is 12. 12 add 5 is 17. Try one more. 3. 3 times 6, 18. Add 5, yes, 23. So that works. Is 121 a term of this arithmetic sequence? You must explain your answer. Well, what we can do is we can put 121 in. That must equal 6n plus 5. And if we move it around, we'll see what we get. 121 minus 5. Does that equal 6n? Well, we'll find out. 121 minus 5 is 116. Yes, that's right, 116. And then we have to see if that divides by 6, and see if it goes in exactly. When? And we just do a division. 116. Divide by 6. 6 into 11 goes once. How many left over? 5. Does 6 go into 56? No. It's not part of the 6 times table. Well, we'll do it anyway. 6 is into 56. The closest to it is 54, which will be 9 times. And we'll take the 2 off. 2. 6 is into 20. Is going to be 3. There we are, it's going to go like that. 19.333. It's not a whole number. Well, this has to be a whole number. No. Now we've got question 4. Got some black pens, blue pens, red pens and green pens in a box, and it's a probability question. Got to work out this sort of thing. There's 200 pens in the box. We're first asked, work out the number of black pens in the box. Well, black has a probability of 0.3, so that's quite straightforward. It's 200, that's our total, times 0.3. Well, because of the tenths, we're going to immediately knock off a naught, so we're talking about 20s. 3 times 20 is 60. That's our answer. The pen is taken at random from the box. Work out the probability that the pen will be green. Let's just go back up to this. Okay, there's only pens in the box. A pen has to be taken. It's 0.3 black, 0.2 blue, 0.4 red. And what will green be then? Well, the total is certainty. So we have to take away all the rest. And that is 0.3, 0.2, that's 5, 0.5, and 0.4 is 0.9. 1 minus 0.9, 0.1. And all we're going to do is pop this down to our answer. And it's perfectly okay. It shows the examiner where things are coming from. That's the answer to that one. 5. Got the ingredients to make 8 shortbread biscuits, and it's made from butter, caster sugar and flour. 120 grams, 60 grams and 180 grams. It's to make 8 of them. Now Tarek's going to make some of these shortbread biscuits, and he's got these ingredients: 330 grams of butter, 200 grams of custard sugar, and 450 grams of flour. What's the greatest number of shortbread biscuits that Tarek can make with his ingredients? So one of these are going to be limiting factors, aren't they? One of these is going to decide the maximum that it can make, because we've got this recipe. And I think the best way to do that, there's a number of ways, is I'm going to work out 3 fractions. We've got 330 over the amount we needed to make 8, 120. This is for our butter. And it cancels down here. 12's into 33, well, we've got a common factor which is 4. No, 3, sorry. Common factor of 3, 11 quarters. Okay, that's that one. And then we do the same for the caster sugar and the flour. So let's just put S for sugar, 200 over 60. Cancel those down. 6 into 20. What we've got? Cool. We can have it, can't we? 10 thirds. Okay. And the final one is 450 over 180. 1845, what's the common factor? Common factor is 9. 9's and 18's 2. And 5, isn't it? Yeah. That's 2.5 mixed numbers. This one is 3 1/3. This one is 2 3/4. Okay. Which one's the smallest fraction? This one. This is what limits us. So let's just see. We know that that is 2.5 times bigger than the 8. So we've got 8 cakes we can make times by the 2.5. Put decimal in now. And we'll put the answer in here. And what is our answer going to be? Well, 2 times 8 is 16, and a half of 8 is 4, 20. We can make 20 biscuits. That's it. Okay, we've got this question 6 now. A, B, C, D and E, F, G are parallel lines. I always like to map these out. A, B, C, D. So that line there and this line here, they're parallel. BC equals CF, BC equals CF, so those lines are the same length. Okay. Angle BFE equals 70. That's this one here, BFE, 70. Work out the size of angle marked X. When I get these, I like to extend these lines a bit. Just gives you a better idea of what's going on. And so this 70 degrees here will equal this 70 degrees here. And that will also be 70 degrees there. Now these two here, all you have to do on your diagram is tell them what they are. They're corresponding. These two are alternate. We've got 2 lines that are the same here. Same length. And that is my isosceles triangle. That's the X we're trying to find there. Just turned it around a bit. There's a 70. And as it's isosceles, that must be 70. And 180 degrees, this is X now, minus the 2 70s. Well, 2 70s are 140, aren't they? So X must equal 40 degrees. X equals 40 degrees. Okay, and they want to know what this is, so we have to say isosceles. Well, we've got this one about a questionnaire now, and Martin wants to find out how often students use the local tram service. He uses this question on the questionnaire. So there we go. How often do you use the local tram service? Little, sometimes a lot. It's all a little bit vague. Write down two things wrong with this question. Well, it's vague is one thing, but we say no time scale. And the second thing wrong, what if nobody uses the tram at all? No, zero selection. Design a better question for a questionnaire for Martin to find out how often students use the local tram service. So I think we'll put a time scale in. How often? And we'll put some boxes in. We've got this question 8 now with all this information about milk being sold in half-pint bottles, 1-pint bottles and 2-pint bottles over a weekend. And what are we asked to do? How many 1-pint bottles were sold on Sunday? Well, I think the easiest way to do it is we'll put down, make it to a table and just put all the information in and see what we got. So we've got half-pint, 1 pint, and we've got 2 pints. Fill in what we've got. 46 of the bottles were sold on Sunday, so we can put that. These are totals over here. So if 46 of the bottles were sold on Sunday, and 15 of the bottles sold on Sunday were 2-pint bottles, so that goes in here. And we've got 31 of the bottles sold on Saturday were half-pint bottles, 31 in there. 22 of the bottles sold were 2-pint bottles. 22 of them were, we'll put totals down here. And 30 of the bottles sold were 1-pint bottles. 30 there. And that should give us all enough information to fill the rest of this in, and we'll see how we get on. So, alright, we know there's 100 in total. So if 46 were on Sunday, that means 54 were sold on Saturday. Also, we know total of 22 2-pint bottles. So if we take the 15 off the Sunday, we know what we had on Saturday, which will be 7. And because this is 54 and this is 31 and that's 7, we should be able to, let's see, 31 and 7 is 38. If we take it from 54, 38 from 54 is 16. Check these in a minute anyway. Okay, that means we can work out this one. Total was 30, so it's 16, so this must be 14. Okay, now we finally go check this one up here. We've got 15 and 14 from 46 will give us this lot over here. So let's have a look. 15 is 29, 17, won't it? And we'll do this. 31 and 17 will be 48. Now, that was 100 down there. This should add up to 100 as well. 48 and the 22 is 70 and 30. Yes, it all makes 100. Good. So we've got our answer. How many 1-pint bottles were sold on Sunday? 1-pint bottles on Sunday. Okay, we've got this question now. Question 9. Diagram shows a container for oil. It's in the shape of a cuboid, so they're all right angles, and it's empty. It's got to be filled with oil, and they're going to use bottles to do it. Each bottle contains 3,000 centimetres cubed, and it costs £3.50. Sally must not spend more than £6 buying the oil. Can Sally buy enough oil to fill the container? So let's go backwards. We've got to work out the number of bottles and times that by 350, and that'll tell us whether it's more than £60. But before we can work out the number of bottles, we need to work out the volume of this cuboid. Now, the volume of a cuboid is length times width times height. 50 times 40 times 30. Do all the noughts first. 5 4s are 20 times 3, 60, so it's 60,000. And then we have to divide that by the amount in one bottle, 3,000. 3's into 60, 20 times. So it's 20 bottles. And what's the cost of those 20 bottles? 20 times £3.50. Well, 3 20s is 60, and a half of 20 is 10, so it's going to be £70. It's too much. No. Question 10. So we've got some algebra now. We have to expand x times x plus 2. So everything outside the bracket multiplies x times x squared plus x times 2, well, we show the number in front, 2x. One mark there. Expand and simplify. We'll expand it here again. 3 times y, 3y. 3 times 2, 6. It's positive. This one, 4 times x, 4x. It's positive. And this one, 4 times minus 1, well, it's 4, and it's a positive times a negative, so it's negative. Then we simplify. Collect the like terms together. If there are any, we'll put them in alphabetical order, so I think we go 4x first. This won't be absolutely necessary. Plus the 3y. And then the only thing that really changes is the 6 minus the 4, positive 2. Same sort of thing with this one. Everything multiplied. We're going to do it like this. Multiply that one first, then this one. It doesn't matter the order really. And then finally we do this one. So let's do that in that order. 2t times t is going to be 2t squared. 2t times 5 is going to be 10t. And it's positive. And this one here, over the top now, minus 3 times t is going to be minus 3t. And then we've got minus 3 times plus 5, well, it's 15, and we just look now at the 15, and it's minus times a plus, so it's minus. Collecting the like terms, well, there's only one term in t squared, 2t squared. We've got a plus 10t minus 3t, plus 7t, and then we've got the minus 15. Okay. Factorise. So we've done the expanding brackets, we're going to factorise. What are the factors of this lot here? Well, we've got a common factor of 4 in that 8 and a 4 in that 12, and we've got an A there and an A there, so we can take out 4A, and that's going to be 2A plus 4 to the 12, 3. That's it. Factorise y squared minus y minus 2. Okay, they're both going to have a y here and a y there. We have to look at a common factor that multiplies together to make minus 2, and it's got to add together to make minus 1. Well, the only factors really of 2 are 1 and a 2. And if we make that a minus there and this one a plus, and then we add them together, plus 1 minus 2, we're going to get minus 1y there. So plus 1 and minus 2. Question 11. Manchester Airport is on a bearing of 330 degrees from a London airport. A. Find the bearing of the London airport from Manchester Airport. Well, the way I like to do these, let's put London here. Manchester, say, well, 360 would be all the way around, so Manchester's going to be up there. Draw in the north. That's the bearing there, and that's the 330. We want to find the bearing from Manchester. This is Manchester, this is London. This way round now. There. They're always measured clockwise from north, so a good way to look at this, the angle there is 30 degrees. 330 plus 30 must make the whole circle, and using our alternate angle business, that must be 30 degrees as well. So a straight line is 180, 180 degrees minus 30 degrees equals 150 degrees, and that's our answer. That's our bearing. The London airport is 200 miles from Manchester Airport. The plane leaves Manchester Airport at 10 AM to fly to the London airport. The plane flies at an average speed of 120 miles per hour. What time does the plane arrive at the London airport? Well, if we've got 200 miles and we're flying at 120 miles an hour, after 1 hour it's got 120. It's got another, what to do? Another 80. What fraction is 80 of 120? Let's have a look. Two-thirds. So it's another 2/3 of an hour. So we've got 1 hour plus 2/3, and 2/3 of an hour is 40 minutes. What time does the plane arrive at the London airport? So it left at 10 AM, takes an hour and 40 minutes to get there. 11:40 AM. Okay, we've got question 12 now. Complete the table of values for y equals x squared minus 3x plus 2. They've given us them already, and we've got to fill it all in. So we'll put the value of x equals 0 in. So that disappears, it must be plus 2. Now put the value of x equals 1 in. That's 1. That will be minus 3. 1 minus 3 is minus 2, plus 2 is 0. Put 2 in now. 2 squared is 4, and 2 3s are 6, 4 minus 6 minus 2 plus 2 is 0 again. The final one, 4 squared is 16, 3 4s are 12, 16 minus 12 is 4, plus 2 is 6. Okay, now we've got to plot it. X equals minus 1, y equals 6, x equals 0 plus 2, 1 is 0, 2 is 0, 3 is back up to 2, 4 is up to 6, and 5 is 12. So typical quadratic, we just plot that. Dip under a bit. And then we've got the fine thing. Find estimate for the solutions of the equation x squared minus 3x plus 2 equals 4. Well, this is x squared minus 3x plus 2 equals y. So when y equals 4 is here, we have one value here and one value here. Our values are, here looks to me around about minus 0.06. And the other solution equals 3 point, well, they're going to be symmetrical, so 3.6. Okay, we've got this one. Question 13. 18 packets of sweets, 12 boxes of sweets. They're all in a carton. And we've got the mean number of sweets in all the packets and boxes is 14. Mean number of sweets in the 18 packets is 10. Work out the mean number of sweets in the boxes. So I think we've got to work out totals first. So let's do that. The total of all the sweets in the packets and the boxes. So the grand total will equal 30 times 14. Well, 3 14s is 42, and it's also times by a 10, so that equals 420. And then this one, the mean number of sweets in the packet, TP, equals 18 times 10, 180. Let's see where we go from there. So that's the total number of sweets in the packets. If we take it away from the total number of sweets, we're going to find the total number of sweets in the boxes. So let's do that. 420 minus 180 8 from 12, 4, 1 from 3 to 240. How many boxes were there? 12 boxes. So the mean number of sweets must be the total number of sweets in the boxes divided by the number of boxes. That cancels. 20. Okay. Okay, we've got this question 14 now. We have a regular octagon, and inside it are two regular pentagons. What we've got to find out is this value x in this triangle here. Now, it may not be immediately obvious, but what we are told is that these are identical regular pentagons. So this length must be the same as this length, which tells us that this is an isosceles triangle. Now, because it's an isosceles triangle, if we can find out this angle here, which will be the same as this angle here, then we can take both those from 180 and we'll find x. Now, to find this angle here, we're going to need the angle of the regular octagon there, and we're also going to need the angle of the interior angle of the regular pentagon there, and take the pentagon interior angle from the octagon interior angle. Now there's a method of finding that, and I'll just give myself a bit more room to go through that. Let's do a pentagon a minute. Not the most regular, but it'll do. Now inside there we can draw two triangles. Okay, now this is a five-sided shape, pentagon. Maximum number of triangles is 3. We know that the angles inside a triangle add up to 180. So the sum of those is 3 times 180. Okay. 3 times 18. Let's say it was 3 18s. 3 10s are 30, 3 8s are 24, so we've got 54, haven't we? Yeah. Or 540 should we say. And then what we've got to do is to find one of those angles out of the 5, the interior angle of the pentagon, we divide it by 5. Well, 5's into the 100, 500 is going to be 100, and 5's into 40 is going to be 8, 108 degrees. Okay, that's the interior. We can do now the formula, I said I was going to tell you the formula. The formula actually is S equals, we can see from that, we had 3 triangles, didn't we, which is the number of sides minus 2. And now we'll find the interior angle for the octagon. So that's using the same formula. That's going to be, this time it's 8 sides minus 2 times by 180, and this time we divide it by 8 sides. 4. Okay, it's a bit easier. So now we've got 6 times 90 divided by 4. Does 4 go into 90? Let's have a look. Well, I can take 2 into the there, and I can take the 2 into the 90, or take 45. So that's going to be 345. So 3 4s are 3 4s is 120, 3 5s 15, 135. Okay, and then we have to take 1 from the other. So we've got 135 minus 108. Okay, what's that? 35, 25, 28, 27. 27. And from our triangle, there's x. We've got 27 there. We've got 27 there. So x equals 180 minus 2 times 27. Well, 2 27s are 54. 54 from 180, well 60 from 180 is 120, 126. Done. Question 15. Sue works for a company that delivers parcels. One day the company delivered 80 parcels. That might be a useful figure. The table shows the information about the weights in kilograms. Okay, complete the cumulative frequency table. By the time the weight is got to 1 kilogram, 19 of those parcels are 1 kilogram or less. So that first one is 19. Now what we need to do is, for the second one, the number of parcels that are 2 kilograms or less are a combination of 19 and 17. 19 plus 17. Okay, 36. That goes in there. And we carry on like that now. We add on the 15, the next one. And then, what have we got to do then? 12, isn't it? 63 goes in there. And then adding a 10 on 73. And the check, the final one is 7. 7 added on to 73 is 80, which was our total. Okay, what have we got to do now? On the grid opposite, draw a cumulative frequency graph for your table. Okay, that's that. This information here then. Okay, we've got 19 of them are 1 kilogram or less. So let's put that in. 19, just there. 36, 2 kilograms or less, just there. 51, 3 kilograms. 63 is 4 kilograms. 73, 5. And so it's 6 kilograms or 80. Try and do my best line. Call it an ogive or ogive. And now we'll have a question. Sue says 75% of the parcels weigh less than 3.4 kilograms. Is Sue correct? Let's have a look. Well, the total is 80 parcels. So 3/4 of 80 is going to be 80 times 3/4. I bet you know it's 60 anyway, but we try. Do it this way. 20 times 3, 60. So let's put that line in. And what I like to do is just bring this, where it crosses the ogive, bring this thing down like this, which is 3.6 kilograms. So actually, 75% of the parcels are 3.6. Let's look at this carefully. Sue says 75% of the parcels weigh less than 3.4 kilograms. Well, this curve is a cumulative frequency diagram, and it's taken from bands of weights, say weights between 3 and 4 kilograms. How do we know that the weights between 63 and 51 that were in this band, between 0 and 4, how do we know they didn't all weigh around about 3.1 kilograms or 3.2? Or on the other hand, how do we know they didn't all weigh around very close to the 4 kilogram mark? So, it looks very clearly that 75% of the parcels weigh less than 3.4 kilograms. It could be, but we don't know for sure. And I think as long as you reason that out and put it into the wording that you put down there, it's going to be okay. So I'm going to write this. In fact, you could elaborate on this and say the only certain thing you can say is that the 75% of the particles must be between the 3 and 4 kilogram range. Okay, done. Okay, in this question 16 we've got a trapezium, ABCD, and a rectangle, STUV, and what I've got to do, all the measurements in centimetres, they both have the same perimeter. We have to work out the length of ST, that's this length here. So I expect when we do all of this, the x is going to come out as a value. We'll be able to put the x value back into this. We can then find out what ST is. Okay, let's give it a go. So the perimeters are equal. Right. And what's the perimeter of this first one? We go ABCD, so we've got 7x minus 2 plus 5x coming down here plus 9x minus 2 plus another 5x. I'm going to simplify that now. Right, let's collect all the x's together. A 7x, a 5x, a 9x and another 5x. So we've got 10x, 19x and a 7x, 26x. And the numbers, we've got a minus 2 and a minus 2, so that's minus 4. And we know that that equals the STUV perimeter of the rectangle. So let's start from that. We've got a 5x plus 5 plus 4x, and we're going to go along that side and then up there again, so there's another 5x plus 5 and another 4x. We've got two of those, and that is then 5x plus 4x is 9x times 2, 18x. We've got 2 times the 5, 10. Okay, so now we know that the 26x minus the 4 must equal 18x plus 10. Let's get all the x's on one side and all the numbers on the other. So 26x, bring the 18x over, minus the 18x, that's going to equal, bring that minus 4 to this side, 10 plus 4. So we've got 26x minus 18x is 8x equals 14. X then equals, divide both sides by 8 rather. Seven quarters, 1 3/4. It's going to be easy to put it in decimal. And what was our ST again? 5x plus 5. So multiply this out, 5 5 is 25, 5 7 is 35, 37, 5 1s are 5, 6 7 8, 8.75 plus 5, our answer must be 13.75. Now we've got these two simultaneous equations. Now they're both linear equations. If it was just this equation on its own, there'd be many values of x and many values of y which would satisfy this equation. But we've got two equations, and there's going to be, if we drew this on a graph, there'd be two lines and they cross at a point. Now what I'd like to do to solve them for x and y is first to label these equations. That one's equation 1, this one's equation 2, and I need to eliminate either the x or y, and I think what I'm going to do is multiply this equation by 3, which will give me 6x, and this one by 2, which will give me number 6x, and then I could either add or subtract them and get rid of the x that way. Okay, I think it's going to be subtraction anyway. Right, so we've got multiplying by times by 3 gives this. 3 times 2x, 6x. 3 times 3y, 9y. And then because we're multiplying by 3, that just becomes 2. And I'm going to call that equation 3. Now I'm timesing this one by 2. 2 times 3x, 6x. Minus, this time, 2 times 4y, 8y. 18 times 2, 36. Well, to get rid of this 6x, I'm going to subtract one equation from the other, and it's better to subtract this equation here from this one. So I'm going to subtract equation 3 from equation 4. If you want to, you can rewrite these a minute. Minus 8y equals 36 minus so the x's go, no x's. Minus 8y minus a 9y now. That's going to take us to minus 17y. 36 minus 2, 34. That looks nice, doesn't it? So y is going to be 34 divided by minus 17 minus 2. And now we just put this minus 2 wherever we see a y, and we'll put it in equation 2, and then we can find x. 3x minus 4 times the y, which is minus 2, equals 18. Minus 4 times a minus 2 will be plus 8. It's 18. So take the 8 from both sides, 3x equals 10, x equals 10 over 3, which equals 3 and 1/3. And do place them in the correct place. So that was there. And it's okay to do a little arrow like that, that's okay. Minus 2. Done. Question 18, we have to rationalise the denominator of 10 over root 5. The way we do that is to do root 5 over root 5. We're going to times them, of course. And root 5 over root 5 is 1. Any number over itself is going to be 1. So we end up with 10 root 5 over 5. A square root times itself is going to get back to its original number. The 5 then cancels with the 10, and I think that is the simplest form. Well, we've now got this one with working out volumes. I think this video is getting a bit long. And there's only 4 more questions to go, but they're all quite complicated, so I'll put them in another video. But let's have a quick look. Yes, we've got a vector one, bit of fraction stuff to do, and this, well, looks very strange, but I'll do that on another video. Okay, bye.